Hey friends, it's me, CM Cabby. How does my mic sound? And with the background music. Hopefully okay. Um, and I'm back here today to introduce a very special creator-focused live stream to jog your memory. On March 25th. We had John, aka Ursus, go over how to create a character in MapleStory Worlds. So today he is back for part 2, where he'll be going over how to create player stat systems, and just basically building on what he started on the March 25th live stream. I will be back at the end of the stream, but for now, I'm gonna let John take it away.
Awesome, thank you so much, Kavi. So today, like Kavi mentioned, I will be doing a continuation of the previous live stream. If you remember, we built how to create a skill system, and we implemented some skills, and we took a look at some of the logic for that. But now let's take a look at take that a little bit further. And we'll go into how damage works, how stat scaling might work, level systems, and how to affect different defense values, attack values, how much damage do you take from the enemies, things like that. So we'll go into all of that today, or as far as we can in the time that we have. And so I guess to begin, let's go right into the demo. So let's take a look at what we have here. So same scene as before. We have our enemies. I just died, sorry. But we also have a level bar. So we can see the level of my character here. And I also have actually, let me try attacking first. You'll notice that I can attack, but the damage is very low. That's because my stats are not updated at all. So let me try increasing my stats a little bit. For warrior, it's strength and dex. So let's try attacking now. And the damage has gotten a lot higher. And if I use my skills, you can see that it's doing much higher damage relative to my base damage value. I can also level up. And leveling up brings my attack, or it brings my health up, and I can deal more damage by assigning more skill points. At the moment, I don't have any ability point assigning. Right now, I just have it so you can infinitely just assign ability points just for the sake of testing, so we don't have to watch me try to level up. But that's basically the gist of it. So we'll take a look at some of how this all works. Just to go into a little bit more of the demo here. We also, as a part of my my demo, let's go to the stats and player. Variable component. So we have my level value here. Double check to make sure. I'm not sure why this value is not showing up in the inspector. Okay, there we go. That was weird. Okay. So if I set my value, I can reset my level to something bigger. I can also set my monster value. So my monsters currently have a level of 60. So they're level 60, and I was level 1. So it was an instant kill. So let's kind of make them the same level now. So both 50-50. And if it all works, then it should be dealing less damage to me. So before, I don't remember how much it was before, but let's try increasing the health. Increasing my level even further. Bear with me here as I find the component. Okay, so let's say I am level 100. That might be too much because the enemies are going to start missing. I believe something is wrong, but we'll go into that in just a bit. But I'll walk you through some of the logic going on here, so you can get a sense of what the intent was. Not sure why there's a bug here with the level right now, but the logic is where the higher your level is, the less damage you take from the enemy, and there's kind of like a level dependent system where depending on the difference between your player and your monster, you will take less damage. And if you're a higher level than the enemy, then you will deal more damage. Because I don't have time to debug that, I'll just walk you through the logic. And if you guys see anything wrong with my logic, then feel free to point it out. But with that, let's go right into what's happening behind the scenes here. So first and foremost, we have our player info component. So we have the stats value here, and this stats is just a struct. So let's open this. So we have a base character stats. So we have HP values, we have defense values, we have a level, power, MP, and final defense. MP is not implemented at the moment, but each of these have various common functions that we can, grab the player or character value. So both the enemies and the players have their own version of these character stats, and as you can see here from the inherited or extended components here for the monster stats as well as the player stats, and each of these have different types of functions in here. And depending on, so the reason why we have these inherited components is so that when we have dealing damage either from the monster side or the player side, all we have to do is just grab the parent, or we don't need to know the exact type of the monster type or the player type. All we need to know is that we have the character stats, and we can just grab, power values, defense values, how much damage you deal, things like that, without having to manually reference and kind of try to instance the component, or I guess get the type reference. So let's take a look at our player stats first. So we have a lot of different functions here, but let's start with the initialization here. So in our initialization function, this is being called from our onBeginPlay, and we are passing in our entity. So from within our initialization function, we have our set to base stats. So notice my little note here. At the moment, there is no saving, so every time you press play, it's a new game. And when you start the game, we'll initialize the HP and NP values to 50. We'll set the mastery. This is going to be in regards to your mastery value, so that your minimum and your lower and upper range of your damage kind of gets closer and closer together. So when you deal damage to the enemy, there is a high range and there's a low range. And having a higher mastery value will kind of bring the lower range up a little bit so that it's kind of closer, so your damage value is a little bit more consistent. This defense value will kind of determine how much damage you take from the enemy. So at a base, we start at 5%. So this is percentage based. Same with the mastery, this is also percentage based value. And then we also have a player stats enum. So this is just a logic script with some integer values. This is basically intended to have more of an indexed enums. So I can utilize these values as indices for things like, when we saw this previously when we worked with skills, where we don't build the core logic into the UI system itself, but we simply just have the UI interactions self-contained. So the UI is just saying that button 1 is clicked, button 2 is clicked, button 3 is clicked, button 4 is clicked. But as far as what those buttons do, that behavior is handled by our main components, not the UI components. So there's a separation of concern here. So that's primarily why I utilize these player stats enums. So you'll notice that we have our base stats in a table, and each of these I am looping through our player stats enum. And for each of these, so these are the strength, dex, int, and luck, I'm looping through each of these and assigning a base stat value. So at the beginning of the game, we are randomizing a value similar to the way that our character, when you start a new game in MapleStory Worlds, or in MapleStory, sorry, your stat value is initialized to some random value. So you can click that roll button and it kind of randomizes some of your stats. So at a base, we are going to randomize our base stats, all of our values between a value of 5 and 9. And then we have some other values here. So we have added stats. So these are for, let's say you have like a weapon that increases your strength by 1 or by 10, or your intelligence by 5, or these kind of fixed stat boosting weapons. If you have those, then it will be added to your added stats. So we have our base stats and added stats. Percentage stats, so if you have, let's say, some sort of, equip or item that will increase your stats by a certain percentage, this will be utilized. And all of these can be modified as you're equipping items. In this demo, we don't have any items or values that, or I guess any items that modify this value. But this is here so that we can utilize it in the future and start implementing maybe equipment that modify these values and affect stat percentages and things like that. The final stats, this will not, so this is in addition to, similar to the added stats, but the final stats will not actually be affected by this percentage value. So added stats can be affected by percentage value, final stats do not. So this is just a fixed stat value that's added on top of the final calculation and cannot be modified by percentage. Okay, so we have our set to base stats. We also have a calculate class value. So as you know in MapleStory, certain classes rely on certain stat value, whether it's strength, whether it's dexterity. Those are exactly the two that are required of the warrior class. But if you have other classes, then for example, thief, I believe, is dexterity and luck. And magician is intelligence and dexterity, I believe. But those two values will directly impact your damage value. So the way that we calculate here, and notice my note, is that we have kind of hard-coded this so that it's always going to be calculated based on this warrior type. So we have our hero class here, which is kind of stemming from the warrior class. but we are assigning our strength value and our dexterity value as our primary and secondary stats. So we have this formula here. So this is just a formula. It's kind of out there in the ether. You can find most of the formulas that I'm going over here online. People have done a lot of different types of kind of calculations of the formula. There's a pretty good guide out there that kind of shows all of the different formulas and things like that. I'll try to get into as many of these as I can, but for the sake of time, I won't go too much into detail, and I encourage you to look online. I should just make a disclaimer. This is anything that you see here in this stream isn't by no means the official, or I guess like a reveal of the official way that Nexon handles these stat values, or confirming whether or not these formulas are accurate or not. This is just one implementation of this value. So that being said, we are grabbing our stat. So in our get stat value, notice that we are doing that calculation of all of our kind of different stat values. Here we have our base stats, and we're adding that to our added stats. Then we are multiplying the percentage value of it. So the percentage stats of the type. So notice that we are indexing our stats based on the type. So this will be based on the player stats enumerator value, and this will be utilized in in UI when we kind of trigger button presses. Everything will be kind of based around this index as far as identifying which stats are going to be modified and manipulated throughout. So we have our base stats, added stats, percentage stats, and then our final stats here. Just adding these together, and then we are calculating the percentage value. This is going to be an integer number from 0 to 100 or plus, over 100. We're dividing it to get the actual percentage multiplier, and then adding our final stats in. So we're getting that for both strength as well as our dexterity. So we have our primary stat and our secondary stat. So our primary stat we're multiplying by 4, and we're going to add in our secondary stat, and that will be our final job class value. This doesn't necessarily mean that this is the final damage value. We'll get into this, but this job class value will be very important for when we actually start calculating our upper and lower ranges for our damage. Okay, so we have our calculate class value here, and we have a job class value ready so that we can utilize it for when we start calculating upper and lower ranges of damage. We also have our defense value. So if we look down here, we have our final defense value being assigned here, and we have this long formula here where we have a certain dependency on strength and dexterity and luck. So these three stats here are going to be calculated into the final defense value. So here we are multiplying 1.5 by the strength, and then we are also getting 40% of our dexterity final value, adding that to our luck value, and that's going to be our defense value, and then adding our added defense. So defense coming from equipment and things like that. Then we are going to multiply it by our final defense value that we initialize here of 5%. And this value is going to be what we utilize to calculate our upper and lower defense values as well. So it won't always be a consistent value that we subtract from the monster's final damage. And this is kind of clearly a part where there's a little bit of a bug. So I can't say that this is the correct answer because there's something going on. I'm not sure. I didn't have time to really fix it. But I mean, as far as the core logic goes, hopefully this will at least provide a guide. And if you do follow along, maybe you can fix this bug before I can. But if you do follow our Discord, I will make sure to, once this is fixed, to also have an announcement out as far as what was going on there. But okay, moving on, we have our so we have our calculate defense value, and then we also have our level advantage percents. So this will be a whole kind of table or array of percentage values that depend on the difference between your level. So this is kind of your level subtracted by the monster's level, and that difference will determine how much damage, and it will factor into the final damage value. So if there's a higher difference in your level, then there will be you will be able to deal more damage. But if there's a if you're lower level than the enemy, then you'll deal much less damage. Okay. So I'll go into exactly how these percentage values are utilized. We will grab the difference and turn that into an index that we can utilize inside of this percentage value here, and we'll kind of see that in just a bit. Okay, so that's all of our setup. We have all of the values that we need to start calculating our values here. And then inside of our player info component, before we get into the UI stuff, so this is initializing UI and setting the UI values into our UI system, but we'll get into that in a minute. Before we do that, I want to actually go into how damage is calculated. So let's go into the player attack component here. And we have our calculate damage here, calculate damage function here. And we also have a get power value. So we're grabbing the attacker and we're getting the power value from our player, and then passing in the monster stats. So inside of our monster, so we have the stats value for both the player as well as the monster. We'll go into the monster side after we kind of do a full run through of the player side. But from our player stats, we have our get power function here. So here's where we have the get upper damage and lower damage range, and we are randomizing a damage value between the lower and upper ranges here. So inside of our calculate damage, we're grabbing that damage, and then if we have attack info, so this is the skill. So one modification that we've done since the last live stream is we have our skill data here. And this damage value used to be fixed damage. Now it's a percentage value that will be added upon the base damage value of your player. So whatever your final damage output of your character is, we will add 220% of damage. Or we'll have a multiplier of 220%, 2.2, into the final damage output value. So whatever the value that comes out of our upper and lower ranges here, that will be multiplied by this damage output value here, 220, 110, 150 value here. So player attack. So if we have skill information, then we are going to grab the final damage, and we're going to turn the power value into percentage value and multiply our damage output by that percentage value. Then if otherwise, we're just going to output our final damage value. If the final damage value is greater than 0, then we will return the final damage value. Otherwise, we'll return -1, which will trigger the miss text. So if we return 0, then it will literally return 0. If we return -1, it will result in the miss text showing up. So if you were implementing combat and you were trying to figure out how to get the miss actually working, this is just, you just have to check for it and return -1 for 0 or lower damage. Okay, so now that we have that understood, let's get into the actual get power function and take a look at some of our calculation for our upper damage range and our lower damage range. So I'm going to close out all of these so it's easier to look at. Okay, so we have our two functions here and we have our get power. The upper damage range is going to get our get level advantage multiplier. So that is going to be our percentage value here that kind of calculates how much damage you're dealing depending on the difference in your level. If you're a higher level, you should be dealing higher damage output. If you're a lower level, you should be dealing lower damage output. So if we open up this function here, we have our level difference. So we are grabbing our current level. So this is the player's level subtracted by the level of the defender. So whoever we're attacking. So we passed in the defender's level, and we're subtracting our level from that from the defender's level to get the level difference. Then we are turning that into an index. So we have our clamp value, and we are passing in our level difference. So let's say, for example, the player level was 50 and the monster level was 10. Well, actually, let's flip that around. Let's say that the monster level was 50 and our player level was 10. Then we would have a difference of -30. So our level difference value is -30. So what does that mean? So when we turn that into an index, we have basically, we have a lower cap of what is the lowest level that we will actually calculate, or what is the lowest level difference that we'll actually calculate, and what is the highest level difference that we will actually calculate. So if the level difference is -30, then we are going to add, so we're adding 41 so that anything lower than a certain amount will be, anything lower than 41, we will always have, so we're assuming that, sorry, let me clean up my wording here. We are assuming a maximum negative value of 40. So if the player difference, if the difference in power or the level difference is -40, we're going to add 41 to that as the lowest level that we will possibly account for. And we will add 41 to that, which will bring our value up to 1, which is the first index of our array here. So if there's that much of a level difference, then you will basically deal 0 damage to the enemy. In contrast, notice that we have our clamp value from 1 to 46. So anything over 40, let's say if it was 41, the minimum clamp value is 1. So if you have a -41 level difference, it will clamp it to 1 so that the starting index is always 1. So anything bigger than a 40 level difference is always going to be 0. Then incrementally, depending on how much of a level difference you have, it will start to kind of be able to deal higher and higher damage value up to almost 100% of the full damage output. Then we're getting into the positive. So notice that our cap is actually 46. which means that we have at if we have a positive level difference instead of a negative level difference, we will be able to deal more damage output. However, we're going to cap that so that you can't, no matter how much greater of a power difference you have or a level difference you have, it's always going to be fixed to this highest 20% damage boost. Okay, hopefully that makes sense. So we are grabbing that index now. We're turning that level difference value into an index, and we are going to turn that into the final level damage percentage value. Then we have that percentage value here, and we are multiplying that by our job class value that we took a look at earlier. So we have that job class value that's dependent on the job primary and secondary stats. And that damage is going to be multiplied by the level advantage. So that's our upper range. That's the maximum damage that you'll be able to deal. Then at our lower damage range is just simply going to be our mastery value. So the lower damage range, we are grabbing the upper damage range. So inside of our get power function here, we're storing the upper damage range here, and then we're going to pass that into our lower damage range so we don't have to recalculate that again. And we're multiplying that by our mastery value. So we have our base stats here, and we have our mastery value of 20%. So whatever your upper range damage value is, we're going to multiply that by 20%. And of course, this would likely be manipulated by skills or passive skills that you implement that can modify this value. For now, we're just going to hard code this value in. So we have our upper and lower damage ranges. Then we're going to randomize between those two values. And that is going to be the final damage output that we deal to the enemy. And that's really it. That's kind of how the player stats work. As far as scaling based on level and dealing more damage depending how much greater of a level you are, and having different stat values manipulate your character stats. Let's get into the defense values here. And to calculate, I guess, to get into defense, we'll first have to take a look at our monster. So we have our monster, and we also have a monster stats here. So monster stats, we have an initialized value here, and we're simply going to get the monster's level. So this is just going to be a hard-coded level that we add to the property inspector. You can implement your own leveling system with the monsters, or just have different models, perhaps the same models, or have a data table of different kind of model IDs, things like that, so you can manipulate the level depending on the map area, things like that. But we're just hard-coding this level now. So we have our level, and we're calculating the HP value here. So we have our baseline HP value here, and this baseline HP is going to be dependent on the monster's level. So if the monster is 1 to 3, then we're going to have a baseline of 5 multiplied by the level, and adding 10 to that. If it's between 3 and 10, excuse me, we're going to have 15 multiplied by the level, and then subtract 25, and so on, until we have 180, where we have 1000 HP, sorry, 10,000 HP multiplied by the level, subtracted by this value, and then up to level 300 is going to be the ideal cap for this monster. So anything between 180 and 300 is going to have 20,000 multiplied by the level subtracted by this value here. So that's our baseline HP value. Then we're going to calculate our level multiplier. So if the level is less than 29, then we will just return 100% of the HP. If the level is less than 100, then we're going to return double the baseline HP. And then between 100 to 109, we're going to use this formula to calculate the scaling value. Then 109 to 159, we're using this formula to calculate the scaling value. And this is just to scale the HP values depending on the level bracket that it's in. Okay, so we have those values here. We have the baseline HP and we have the level multiplier to calculate our monster health. Then we have our monster attack, where we where we deal damage to our monster. Where the monster deals damage to the player. So we're grabbing the defender and assuming that the player is the defender is a player. We're grabbing the stats value and then grabbing the calling the get damage function that we saw. So we're passing in this monster. Sorry, I'm losing my voice a little. We're passing in the monster's level and the monster's base attack value, or I guess the power value of our monster. And we will call the get damage. So now the monster is dealing damage and now we need to defend against that damage. So we have two damage values, or I guess we have two functions here for defending. We have the get upper defense range and we have the get lower defense range. So in our upper defense range, we have actually for both, for upper and lower defense, we have two different multiplier values here. So we have multiplier A and multiplier B, and this is just part of the formula for proper defense scaling. This value, so we are passing in our level to this multiplier, and we're going to calculate A and B depending on the level differences, and depending on the difference in level, we're going to deal a higher amount of damage or a lower amount of damage. And we're going to use these A and B values to calculate our final defense formula here. So we have our monster attack, and we have our final defense value that we calculated based on the calculate defense value here. And we are going to grab our A stat, or I guess A calculation, and then we're going to have our monster attack multiplied by B times the or subtracted by our B times defense. So whatever the monster attack is, we're going to subtract by this multiplier here, B times defense. So we're going to decrease the amount of damage that we deal, or decrease the amount of damage that the monster is able to deal, depending on this B value here and our defense value. So For A, we are going to do this a very similar thing as we did to our level advantage percentage for our attack, but for the defense values, we're grabbing our level difference, and again, we're going to create an index out of it. And we are going to clamp the defense value of 1 to 10. And depending on that value, so if the level difference is greater than 0, then we're going to clamp it from 1 to 10. So we have a maximum of 10 level advantage. And depending on the difference, we're going to be dealing more and more of the defense value here. Then, as the level difference gets more and more negative, then we're going to increase that final A value here. So the final damage output is going to increase depending on how much of a level difference there is. For the B value, we're again clamping the value, and we have, this time we have a negative level difference. So we are again assuming a maximum of -30 to start at an index of 1 at a level difference of -30. And if you have a -30 level difference, then we are going to deal 50% of the final defense value. And then up to the same level, then we're going to deal 100% of the defense value. So that is our upper defense range. And then for our lower defense range, we're going to again calculate that A value, and we're going to multiply 0.85 by the monster attack, and we're going to do the B times defense again. So pretty much the same thing, except the only difference being that we are adding in this 0.85 value here, so that we can kind of lower that defense, have a lower defense value kind of in range here. So between the lower and upper defense ranges, we are randomizing that value, and we're returning the final damage that will be dealt to our player. So we have our monster attack. And we got the damage value. And if the damage value is greater than 0, then we'll return the final damage. Otherwise, we will miss. Okay. So I believe that's everything in regards to the monster side and the player side. So that is how kind of the different stats are calculated for dealing damage. But now let's get into the UI side of things. Let me double check the time here. Okay, so if you get into our UI, we have our player stat demo here, and we have our player stat window. So inside of this window, we just have our player info values here. These are just hard-coded, or I guess not really even coded, and these are just embedded into the UI. But this could, of course, be dynamic based on, of course, should be dynamic based on the actual character name of the player that enters the world and the actual job class for that character. But the top really is just for show, same as the ability points. This is depending, or I guess the ideal flow is that every time you gain a level, you should gain a randomized value of ability points. You should gain 5 ability points every level, and then be able to assign that to your stats, your various stats, as I showed you in the demo. So inside of our stats, we have our stat model here. So this is just a model that I've created. And we are referencing our button value, where we will, if this button is clicked, then we'll increase the stat. We also have the stat number value here that we will manipulate. And then this is just embedded into the UI, the stat title here. So notice that we have indices here next to the stat numbers here. And this is going to correspond to the stats enum that we took a look at before. So as you might guess, inside of our stat window UI component, we have our inside of our init. So in our, I believe I'm calling this from our init client. So on begin play, this is server side because UI is client side. I'm doing a client side init, and we are initializing our stats window, and we're grabbing all of the stats. This is going to be the final stat values of our player. So if we look, we have a get stats function down here, which basically loops through our enumerator and then just gets each stat and the final value of each stat. And we're going to pass that into our initialize function of our UI component, which will start to initialize our base values here. So we have our stats table with all of our stats corresponding to each of the player stats enum values. So we are assigning the text of our stats of our first stat value here by grabbing the player stat parent here, and we grab each of the different childs depending on the index. Then we will grab the stats UI window UI item, which basically this can actually just be renamed as, button, because there's nothing about this that is specific to the stats window UI. This is intended to be kind of separated from the core logic. And all this does is we can call the stat button, and we can set the text of the button, and we can assign a listener to the button to a function where if that button is clicked, then we will call some sort of function. In this case, we're calling our onUpgradeStats function here. Then we are crafting our event here. So we have a player stat increase event here, and we have an increase index and increase value. So we have our increase index and increase value by 5. So every time the value is increased, we will increase by 5. This can, of course, be an increment of 1. Just to kind of show the difference in power values, I incremented by 5, so I don't have to sit there clicking the button, 400 or 500 times. But yeah, so this is, we're grabbing the index, or we're passing the index of the button that was clicked, and we are passing the value to increase, and we're sending that to our local player. So our local player is going to be our player info component here, and down here we have our handle stat increase event listener. So this will call increase stats, and then in turn call our player stats increase stats value here. So when we increase the stat, we are going to grab the index that was passed in from our UI, and then we will add the value that was passed by the event. Then we will recalculate the class value because our values have changed now. So our job class value will now be different. And then we will also recalculate the defense because our defense value will also now be different because our stat values have changed. Okay, So that is our UI side for our stat upgrading. So we click the button, we pass in our oh gosh, where's my player info? We pass in our stats, and we increase the stats, and then we send, because we have to update the UI now that the value has increased, we send we send an event back down from the client-side event, because our stats are going to be server-side. So our stat values are all server-side, and we're going to send the stat update event down from the client, and this is just going to be the index and then the final value that will be updated and reflected in the UI. So player info component keeps disappearing. So we're going to pass in the index that was updated. We're just passing it straight back down back to the UI. And then we're going to pass in our final value, which is going to be the calculated stat value based on all of our equipment values, our percentage values, our accessories, all of that. And that's going to increase, or I guess that's going to be sent back into the UI. And our stat window UI component is going to listen for that, and then call update stat. And then we will grab the index of the stats, and then just call set text and assign the value here. And with that, that's the full loop of the stat system. So based on the system, our damage output will increase based on our level, based on the skill values here. So we only have one value here, but theoretically we can also have multiple tables of our damage output values here, so that let's say we increase our damage value, it can deal more and more damage. But the player still has to be mindful of which stats they're modifying. Some stats, even if it's not class specific, may be calculated into defense values and things like that. So it is not just a fixed value of a skill value that we've done before. Now there is a value, now there is a stats value that we have to start considering as well. So hopefully that makes sense. That is everything for this webinar. And hopefully this helped. And with that, I will send it back to CM Cabby.
Hello. Thank you, John. That was a really good tutorial. And if you have any additional questions, please go to our Discord. All you need to do is drop in to the chat !Discord to get the link. Okay, so I am back with a few housekeeping things before we end the stream. The first one is the 90-day creator challenge. We're getting close to the end, creators, so you have a little over a month to finish your world. The 90-day creator challenge submission period will close on June 9th. So head over to our creator news post to learn more, or you can drop !90day CC into the chat for a link to the website. Next housekeeping item is the creator workshop. Our team is launching the next creators workshop class, and applications are closing May 11th, which is very, very soon. The 12-week virtual incubator program offers a $5,000 USD stipend, technical and business guidance, as well as project promotion. The next class begins on May 27th, and applications are closing soon. So just drop !workshop into the chat for the link to the website and application. Be sure to check out the next stream on May 20th, because we will be showcasing the projects from the last class. What else? Oh, a survey. Okay. if you watched last week's stream and you completed the survey from last week, we'll be actually resending out the survey because there'll be a question that will lead you to a different section so that we can get your thoughts on today's stream. Specifically, we would especially love feedback from creators who watched today's stream. For the link to the survey, just drop !survey into the chat. What else? Oh, for those of you looking to play some Maple Duel, myself, CM, Suki, and some other Nexies will be hopping onto Maple Duel in the next few days, possibly also hopping into a stage channel in the MapleStory Worlds Discord server during those times as well. Dates and times will be posted in the announcements channel in our Discord, so keep an eye on that. And if you see us, you can try and beat us. For the link to our Discord, again, just drop !Discord into the chat. And lastly, like I mentioned earlier, just now, our next live stream will be May 20th at 11 a.m. PDT, Los Angeles time, where we're going to showcase worlds from the first Creator Workshop class. And that is it, folks. If you have, again, any additional questions for John, please hop into our Discord channel, our Discord server, and tag him. He is at Ursus. Anything else? Let me think. Nope, I think that's it. We will see you on May 20th. Thank you, friends. Bye-bye.